Okay, so today we're going to do mostly examples of review work which we've looked at. So there will be times that I ask you to pause and have a go at the questions, but there won't sort of be the my turn, your turn, just so that we get through everything. So the first thing that we'll look at is Pythagoras, so recapping on that. Here we are finding the longest side, we are looking for the hypotenuse, so we're going to use that a squared plus b squared equals c squared, and remember that c is always the hypotenuse, which is the longest side. So if we substitute in what we know, we can say 7.5 squared plus 18 squared is equal to x squared, and then calculate that on your calculator. So 18 squared plus 7.5 squared is equal to 380.25, and then to get x we need to square root on both sides, and you can just do square root answer, and that will give you a final answer of 19.5. So just make sure you're happy kind of with each of those stages there. What we'll go on to now is finding the shorter side. Now this seems to be catching quite a lot of people out, so just make sure that you watch really carefully what I do before you go on to practice. Now the hypotenuse here is 10 centimetres, so we know what that is. So we're looking for a shorter side. So remember, Pythagoras is a squared plus b squared equals c squared, but because we know what c is, we can say we're looking for a or b, and in every case we said, right, let's just say that we're looking for a, so we can rearrange and use the equation a squared equals c squared minus b squared. Now remember, A and B just mean the two shorter sides, so it doesn't matter what you label A and B as, but when we use this equation here, we're going to say, okay, A is the one which I'm looking for, which I don't know. So if I substitute that into here, that means that A is equal to x, so x squared is equal to, C is always the longest side, which in this case is 10, so c squared is 10 squared, take away the shorter side, which I do know, which is 6 squared. So that will tell me that x squared is equal to, and then 10 squared minus 6 squared is equal to 64. And then to find what x is, square root on both sides, and you would get that x is equal to 8 centimetres. Okay, and that is the one to watch out for when you're finding the shorter side. So pause here, have a go at the questions on Pythagoras on the slides. I have put an extra slide with hints on to help you, and then come back and we'll run through some trig examples. Okay, now we're going to come on to finding side lengths using trigonometric ratios, so SOHCAHTOA, like we've looked at over the past couple of weeks. So here we need to find the side of the question mark, so I'm going to label my sides first of all. I know the hypotenuse, this is the angle that I'm working with, so this is the opposite, and then down here is the adjacent. Write out SOHCAHTOA and tick off what you know. Now here I know the angle, so I can tick off sine, cos and tan. I know the hypotenuse, so I can tick off H, and I'm looking for the adjacent, so I can tick off A. And so you can see that the only ratio with 3 ticks is CA, so we're going to be using cos. So CA stands for cos of the angle, which is 40, is equal to the adjacent, which I don't know what that is, that's my question mark, divided by the hypotenuse, which is 9. Now remember here, to rearrange to find what the question mark is, we want to times both sides by 9, because that eliminates 9 from the denominator. So 9 times cos 40 is equal to my question mark, and then I can do that using my calculator here. So 9 times cos of 40 gives me an answer of 6.89 to 2 decimal places. And that would be centimetres. Second example here, same starting process, so label the sides. So this is the angle I'm dealing with, so this is the opposite. Longest side is the hypotenuse, and then this side here would be the adjacent. So writing out SOHCAHTOA, I know the angle, so I can tick off sine, cos and tan. I know the opposite, so I can tick off O, and I'm looking for the hypotenuse, so I can tick off H. And the only one with all three ticked off is SO, so we're going to be needing to use sine. Now SO stands for sine of the angle, which is sine of 30, is equal to the opposite, which we know is 5, divided by the hypotenuse, which is my question mark. Now remember, in this case we need to times throughout by the question mark and then divide throughout by sine 30, and we also spotted that that means in this case we can just swap these around, which tells me that question mark is equal to 5 divided by sine of 30. Ooh, and I would compute that using my calculator. So we have got 5 divided by sine of 30, and that is equal to 10 centimetres. So just be careful when your question mark is in the denominator. Make sure you remember that step there. Last one we'll have a look at, we did cover this yesterday, is finding the missing angle. So the process is exactly the same as at the start as it is for finding the missing side, and then we just need to substitute in. So label your sides first of all. So this is your angle you're looking for, so the opposite is 5, the hypotenuse is 15, and this is your adjacent. Writing out SOHCAHTOA, I can tick off sine, cos and tan because I am looking for the angle which corresponds to sine, cos and tan. I know the opposite, so I can tick off O, and I know the hypotenuse, so I can tick off H, and we can see we need to use SO. So that means sine of the angle, so sine of theta, is equal to the opposite, which is 5, divided by the hypotenuse, which is 15. Now remember, to get theta by itself, I need to use my inverse function, which is sine to the -1, and that's just shift sine on your calculator, which we'll come on to in a second. Okay, so we can say if I were to do sine to the -1 on both sides, that gets rid of sine on the left, so we're just left with theta, and we've got sine to the -1 of 5 divided by 15. Now doing this on your calculator, you would do shift sine to give you that sine to the -1, and then 5 divided by 15, and that'll give you an answer of 19.47 degrees to 2 decimal places. Example 2, label the sides. This is the angle you're looking for. So here is the opposite. Your longest side is the hypotenuse, which is 12, and this is the adjacent. Write out SOHCAHTOA. Again, because we're looking for the angle, we can tick off sine, cos and tan. We know the adjacent, so we can tick off A, and we know the hypotenuse, so we can tick off H. And in this case we can see we need to use K, which corresponds to cos. So K stands for cos of your angle, so cos of theta is equal to the adjacent, which is 5, divided by the hypotenuse, which is 12. And now to eliminate this cos, we do the inverse cos on both sides. And we are left with theta is equal to cos to the -1 of 5 over 12, and calculating that here you would do shift cos to get cos to the -1 on 5 over 12, and that'll give you an answer of 65.38 degrees to 2 decimal places, as this 5 means the 7 would round up, and that there would be your final answer. So use those examples to have a go at the questions on slide 9, and there's some hints on slide 10, and then the solutions on slide 11 for you to mark once you have done those.